All right, so this is lesson 105. It's going to be a weird lesson because I'm really bad at spatial stuff. I'm not so good at seeing things and then be able to imagine where they would be in a different position. But we'll give it a try. So they're going to talk about lines of symmetry. So you can use a line of symmetry to make a mirror image of something. So I cut out all these little shapes, but I think it's going to be really annoying to actually use them. So we're just going to do the triangle shape that I have. So they said the triangle, if I wanted to divide this with a line so that each side would be a mirror image of the other side, I could draw a line right down the middle of this triangle. And if I fold it, each side is the same, right? So this side is a mirror image of that side, or the other way around. Okay, so I can also take this triangle and fold it this way, right? So that makes a mirror image. So there's a line of symmetry. Again, I told you I was bad at this stuff. I had to actually cut them all out. Okay, and again, that makes mirror images. So once you fold it, you won't be able to see anything different. So there's another line of symmetry. Oops, bad line. So that's my triangles has several lines of symmetry. In the book, it has 1, 2, 3, and on my triangle that I folded up, 1, 2, 3, right? Since polygons are regular, means they're the same on all sides, we can find a line of symmetry through each vertex. So I made myself a shape and I tried it out. I won't show you. But the vertexes are the points, vertices. So you can have a line of symmetry through each point. So the triangle has 3 lines of symmetry. So through that point, through that point, through that point. And then this pentagon will have 5 lines of symmetry. So 1, 2, 3, 4, 5, and then it keeps on going. Through each vertex, right? Okay, so example 2, they have a regular quadrilateral, 4 sides, hexagon. How many sides does a hexagon have? 1, 2, 3, 4, 5, 6, right? Okay, so there's a line of symmetry that passes through the vertex and its opposite vertex. So the corners had a square. Oh, there's my square. Okay, so right through the corners. I know I can do the same thing to the other one. So if I fold that, there. You can't see anything from the other side. Same deal that way. So we can find those 2 lines of symmetry. But we can also fold it in half. So that's a mirror image, isn't it? And can I fold it in half this way? Absolutely. So now I have the corners, or the vertices, and then through the middle on both ways. So the square has 4 lines of symmetry, and I could do the same thing for this hexagon, except for I, again, think that would be annoying, but I tried it. So anyway, okay, so that's reflective symmetry. It means it reflects, makes a mirror image. They also have rotational symmetry. So if I take this triangle and I put a pin in the corner and I rotate it, it still looks like the same triangle. And if I rotate it, it still looks like the same triangle. So an equilateral triangle has rotational symmetry. Got it? So that means if you rotate it, it still looks the same. Then example 3, they give you math. And they say, which of these letters has rotational symmetry? So the trick with rotational is imagining you put a pen in a corner and then turn it. So let's see. Nope, it does not look the same. Nope, it does not look the same. Nope, nope. So M does not. A, put a pin in the corner. Nope, nope. Nope, nope, nope. T, obviously not. Nope. Look at H. So I'm going to put a pin in the corner and pretend like that little thing that I messed up on isn't there. So my H is there. Hey, now it's the same. So if I rotate it, And it says a half a turn, that means 180 degrees. So there's a quarter of a turn, there's a half a turn, okay? So 180 degrees is halfway around the circle. So out of those, only H has rotational symmetry. If you turn it, it looks the same, or is a mirror image from reflective. So it could be either way. On the grid, there's an L-shaped figure and its reflection. So remember, reflection means like you turn it over. So here, they're going to leave this. I'm going to erase this line, but I'm going to leave it for right now. So if I have this here and I've got one blank space, I'm going to take my L, leave one blank space, turn it over, and it's exactly reflected, right? So is there? Yes, there is a line of symmetry, and it would be on the 3 right up there. Would it be the same there? No, not so much, right? So the figure on the right is an image of the figure on the left reflected across the line x equals 3. That line right there, okay? Do all reflections have a line of symmetry? So think about that. Probably not. Do all reflections, if they're exactly the same? Maybe. So think about that. Okay, so another thing you can do to transform a figure by moving it, not cutting anything off, just moving it around a little bit. So I have my L-shaped figure, and it's translated 4 units to the right. That means up, down, back, and forth. So I'm going to go 1 unit, 2 units, 3 units, 4 units to the right. So it is a translated image, and there is not a line of symmetry between this and its translation. So we've got reflections, we've got rotations, and we've got translations. Okay, so those are all types of transformations. Watch the video song. It's kind of cute, and I think it'll help you a little bit. Example 6 says on the grid, an L-shaped figure is rotated at 180 degrees. So I'm going to take this, put a pin in it, turn it 180 degrees. And it's combined to form a new shape. Does the new shape have rotational symmetry? So they took, this L. They put a pin in the corner, rotated it around, okay? So the same figure appears. So if you go any other number of degrees greater than 0 and less than 360, they would not have. So in other words, you can't go like this. It has to be 180 degrees, and that's what they're saying. A lot of 180 degrees result in a pair of figures with rotational symmetry. So see if you can figure out whether all of them do. So that's the 3 ways you can transform figures using rotation, reflection, and translation. Okay, so you're going to draw these lines of symmetry. So remember, I could draw a line right through there. I could draw a line through here. So it has to be the same on both sides. If you flip it over, it's almost like turning the page on a book for reflective lines of symmetry. Maybe do the same thing with cut out the letters if you need to. Again, I'm just so bad at this. So don't worry if you're not. I just traced, to make my little L for these, I just traced it and then cut it out and then used what's in the book. So that might be helpful to you. So good luck with this. Hope you're better at it than I am. Take care, you guys.